In the context of kinematics, that is the description of motion, the motion can be described in 3 dimensions and 2 dimensions. In this session, we're going to explain the simplest case of motion in 1 dimension. In kinematics, the one-dimensional motion can be understood as a motion along a straight line, and this line could be along one of the Cartesian axes, for example the x-axis or the y-axis or the z-axis. Or the state of motion can be described in terms of 3 physical quantities: the position, the velocity, and the acceleration. And these 3 physical quantities are all dependent on time. The position of an object is a vector quantity, and as you know, the vector quantity has a magnitude and direction. Here, this car is located to the west of the traffic light, so it has a distance x from the traffic light and a direction to the west. But alternatively, the position vector can be also represented by a vector r, which has a magnitude x and a direction minus I hat. This means that the position vector has a magnitude of x to the west of the traffic light, because here the origin is located at the traffic light. Here it is important to note that any object, whatever its size is, can be idealized as a small particle. The displacement of a particle is a vector quantity and is defined as the change in the position of that particle. Here the car is found at position P1 at its initial position for the first second of its motion at a distance of 3 meters from the starting point, which is the origin. After 4 seconds of the car's motion from the starting point, it is found as a point P2, 300 meters away towards the east. Thus, the position vector of the particle at P2 is 300 meters I hat. As displacement is defined as a change in position, as we said before, so by knowing the final position of the particle P, which has a magnitude of x2 with respect to the origin, and the initial position, which has a magnitude of x1 with respect to the starting point, then the difference between the x2 and x1 give us delta x, where delta x here represent the magnitude of the change in position, delta r, and I hat refer to the direction towards the x-axis. If the change of position is positive, this means that the direction is towards east. However, if it is negative, it means the direction obviously towards west. The final position of the car has a magnitude of 300 meters, while the initial position has a magnitude of 30 meters. By taking the difference between the final position and the initial position, we got a 270. This represents the magnitude of the displacement vector. As long as the car is directed towards the east in its initial motion and final motion, then the final results, which represents the displacement as a vector here, is equal to the magnitude of it, which is 270 meters, and directed towards the east, as I hat refers to the east when it is positive. It must be noted that the magnitude of displacement is called distance. This is not to be confused with the scalar quantity distance. Here, the magnitude between the initial and final position is the shortest distance between these 2 points, as the meaning of the magnitude of displacement is concerned.